Welcome
to the joy of coding.
Hello! Hello, and welcome to episode 318 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. It's March 8th, 2023. Sorry about the delay. If you're watching the live stream, I'm starting a little bit late. I had some trouble with the IRC Twitch bridge thing. It's up, it's running. Thumbs up. Let me switch to my screen and we can get started. Yes, it is March 18th, episode 318. A reminder, no plan survives breakfast. I think I know what I want to do today. I have a general idea, a general plan, but things might go horribly wrong. We might get sidelined, rabbit holed. Who knows what'll happen? We might spend most of the day reading documentation. That's possible. Or we might solve our problems. That's the other thing that could happen. Or somewhere in between. That's all right. We're capturing software development in the raw. None of this is like pre-planned, really. And in particular, the thing we've been working on, I've only been working on it during the stream. So, you know, if you've been watching these episodes continuously, you know, I'm picking up where we left off, and we'll see where things go with this Windows jump list stuff. Before I continue, I want to mention that the agenda that we're looking at is available to you if you're watching this on YouTube. Or wherever you're watching this. It's in various places. So on YouTube, it's in the video description. Same with on diode.zone. If you're watching this on Air Mozilla, it's in the details section over there. And if you're watching this on Twitch, it's down below in the channel details. The agenda is useful. It will be updated as I write stuff into here. It will synchronize in the background, and you just reload the page and get up-to-date stuff, including handy-dandy links that you can click on to follow along. And if you're not already familiar with the episode guide, I want to let you know that there is an episode guide. The episode guide is complete. It's not formatted well, says Ocris. Well, let's take a quick peek. Let's take it. Oh, that's me. Let's take a quick peek at the agenda and see if we can quickly fix the formatting. 318. Oh, yeah, that's garbage. Let's fix that formatting. I've seen this problem before. I think it's whenever I don't supply enough spacing here or something. Like, let's take a look at the markdown today. Here, I'm gonna update and reload. There we go. Better. This is not as good. Let's see if we can do better there. It really doesn't like those triple backticks, eh? I mean, Joplin does, but my script sure doesn't. Do I have to, like, fence it? I can't remember if I have to fence it. Yeah, the whole, like, code formatting thing in my agenda business needs to kind of get rethought. Or maybe needs support, because I don't think the Markdown library I'm using to generate this page is doing the right stuff. So that's no good. Sorry about that. Hopefully I'll fix that someday and I can regenerate the agendas with better code formatting. You'd think I would have caught that by now, but this is a surprise. So what are we working on today? I skipped over the episode guide. I want to jump right into it. We are still working on the jump list stuff. And the week before last, because I couldn't stream last week, we were starting to get into the nitty gritty of writing automated tests, a unit test. I call it a unit test, but it's really it's a unit test. A unit test for the populate method that we added. Like if we take a look at the source code of what we've been working on, it currently doesn't build because we were like halfway through it. But it was jump list builder. It was this populate jump list method that we wanted to write a test for. And the reason this is being such a pain in the butt is because populate jump list communicates, like there's some complexity here, because what it does is it offloads some work to a background thread, and then that work talks to a Win32 API. It talks to Windows directly, the Windows shell, to add things to and from, add things to the jump list. And so whenever we run these automated tests, we have no ability to really control or interrogate the Windows shell for what's in the jump list, so it makes it difficult for us to write a test for it. So I was talking to some people, some sort of Windows experts at Mozilla and who contribute to Mozilla, and what they suggested is what we could try and do is make it so that we can mock out the mechanism that like an interface. How do I say this? Create an interface for how we talk to the Windows shell. Have that basically be a pass-through interface whenever we're running normally. And then whenever we're writing in our tests here, we can like implement a mock version of the Win32 API and sub that in and have populate jump list talk to it. And then we can interrogate that thing because we control it. That's the idea. Now, one of the challenges here that I thought about, I don't know if I sort of thought about it during last episode or I've thought about it ever since then, is the fact that we're hoping to write this as a G-test. G-test is the Google C++ testing framework, unit testing framework for C++ stuff. And we use that internally in the Mozilla code base. Like if we can find a bunch of G-tests that, we can look and crib some examples off of. But like there are, G-test. Where are there some good G-tests? G-test, yeah. Or there's, what am I looking for? What do we normally test fn .cpp? I'm looking for our testing stuff. Like the G-test, I'm looking for some example G-tests. So give me a quick second. I apologize. I haven't really found, I didn't prepare to, like I've only been working on this during the stream, so you're watching me look this up right now. So Gmock is a framework, and let's see if we can find some examples of using mock method, for example. Okay, here's some G-tests. Oh, so they're in folders called G-test. That's the convention. Right. So a bunch of G-tests in here, and what we need to be able to do is mock this thing out and deal with the fact that the work occurs off of the main thread. So our G-test is going to run in its own thread, and it's going to instantiate this a jump list builder thing and call populate jump list, which is then going to attempt to offload some work to a background thread. And I don't know how that's supposed to work in a G-test. I'm actually worried that none of this will work, honestly. Like, I don't know how much XPCOM power we have inside of a G-test. In fact, let me just see here if we do like a components or query interface. Do we do any query interface? Okay, so we do seem to have some ability to do some XPCOM gunk and JavaScript stuff inside of a G-test. So that's good. These are file system mocks. And who uses these? File system mock. Request handler. Test promise listener. See, this is all very encouraging, because we're effectively going to need to wait. We're going to need to wait for our mock object to resolve the promise. Because the way that populate jump list works, like I said, is it offloads work to a background thread, and it returns a promise that resolves when that work is completed. Either it failed or it succeeded. And originally I was thinking, well, what we can do is we can expose a lock on our mock object, like a semaphore, and then we can just wait on that lock. And, whenever that lock is yielded back to us, then we can check. But the problem with that is that we cannot be sure that when we call populate jump list, that our thread execution order, like the background thread, will be serviced and take the lock in time. So we might end up waiting on the lock on the main thread right after calling populate jump list, and then we get the lock, and then our mock object hasn't even been called yet. So what we need to be able to do is wait for a promise. And I was wondering before this episode whether or not G-tests allow us to await promises and how G-tests work with promises. And this is an encouraging find. We've got something called a test promise listener. And let's see how it's used, because we're probably going to need something similar. Maybe we can even like reuse this. I don't know. File system mocks. Test promise listener. Mock promise listener. Is this thing. So like, let's find some tests. API test file system handle. So this is nice. We do get some XPCOM stuff. We get like the preference service, which is good. Test function, create and destroy handles. So these execute synchronously. This is a lambda. That's still executing synchronously. Promise. Assert equal promise resolved. So that's less encouraging. This doesn't actually await the promise. This is presuming that the promise will be resolved synchronously. So that is less encouraging. Let's see if the term wait. Wait for. That might be helpful. Wait for. Variant. That blocks the caller until a Moz promise has either been resolved or rejected. That's handy, and how that works is it will spin the event loop. Okay. So that's helpful. We might want something similar. Let's see if there are other examples of spinning the event loop like this. Under the file system, media does it, network does it, and it waits until something is pending. Here we wait until something is not pending. So this is good. We seem to have mechanisms in place. We just have to spin a nested event loop, which normally I wouldn't say that's a good thing, except that these are tests we're talking about here. So that's good. Now, do we have any way that we can wait for a DOM promise? Because like what we get back from populate jump list is a DOM promise. So let's see if anyone deals with DOM promises here. DOM promise. So these are, yeah, DOM promises. This is a DOM promise. So that's encouraging. So like as I was saying, these ones are not being awaited. I think these might be like special in that they execute synchronously. Promises fulfilled or timeout. I see. I see. How Okay, so here's what we can do then. Our G test can get at the returned promise. Well, see, this is not a Moz promise. This is a DOM promise. How do we work with DOM promises in C++? Then no. DOM promise. DOM promise. Solve callback. Promise native handler implementation. DOM promise native handler allows C++ to react to a promise being rejected or resolved. The promise native handler can be appended to a promise using promise append native handler. Okay. Okay. We can work with that. This class is used to set C++ callbacks once a DOM promise is resolved or rejected. That might be even better. Let's see which one tends to be used more in our G tests. Let's just look for DOM promise listener. Not there. This one is file system mocks uses it in this class promise listener. When we resolve, we call M on success, where M on success is some kind of callback that's supplied. Oh boy. Success handler, error handler. So that's a very sophisticated helper. I don't think we need anything as sophisticated. Let's look at some examples of using DOM promise listener. Yeah, that might be sufficient. We'll just use a DOM promise listener. We get back a promise. And then we'll attach a new DOM promise listener, which takes in two methods. And then what we can do in those methods is we can set a variable that we're like paying attention to. Like we'll have a success or an error, and then like I like this sort of I like this pattern actually. Wait for blocks on call until I'm. That's a Moz promise, but it's like you can wait for a success, wait for an error. Then we use DOM promise helper or DOM promise listener. Supply these two, wrap up success and error, and then we'll assert that success is some. And maybe we can turn that into a helper. Maybe that would help some other people use this. Do we just have like general G-test helpers? I think I saw some. Helper. Excuse me. Testing. Here we go. Moz assertions, Moz helpers. Like disable crash report. We could put some helpers here. Okay. All right, I think we've got a way forward. Thank you for saying bless you in the chat. I apologize for sneezing almost directly into the microphone. I realize it is a wide diaphragm, high definition microphone, and you probably got that sneeze in HD. Sorry about that. Okay, so I think we've got a plan. Our research here has emitted a plan. Let us now write that plan down. So what we can do with this, I'm gonna put it all after this garbage. That's probably rendering poorly. We're going to be calling the populate jump list method on the Windows, the builder, jump list builder. And then what we can do is take the returned DOM promise and use a DOM promise listener. Here's our example. Use a DOM promise listener to set up some Lambda functions that write into some maybes like this. And then we spin the event loop. Spin the event loop like that prior example to wait until the promise either resolves or rejects, and then we assert the resolving or the rejecting. Excuse me. Oh man, where's that sneeze coming from? Okay, that sounds good. Let's get ourselves to the point where this stuff compiles now. Where had we gotten to last week? I've just tried to build and it failed. And I tried to build both debug and default. So let's just do the one debug build and let's see what it says to us. I'm just gonna mute for a second while I blow my nose. Can I mute audio input capture? There we go. Muted kappa. I don't know what that means. I still don't know what kappa means. Okay, so there's a lot of complaining from the compiler here. A lot of this is like warnings about stuff inside of third-party libraries. Good job. And then we start getting into the useful stuff. Jump list builder H, error, field of type Mozilla reentrant monitor has a private default constructor. Oh, that's right. That is right. We ran into this last week and I didn't know what it was. So what it's complaining about, this is going to be fun. What it's complaining about is this, where we're passing in a reference and then we are assigning. This was like a why did we need the reentrant monitor? Oh, because this is the thing we need to take a lock on. We need to take a lock on things. Right. This is the actual, this is like the pass-through implementation. which isn't great, right? Because this means that every call will take a lock and then yield the lock and then take another lock and then yield the lock. Whereas before we would take a lock and then call into each of these functions in the same scope and then yield the lock. And we've lost some of that here. And, you know, you want to avoid taking locks when you can. Kappa is used to convey sarcasm or irony. Oh, I see. I don't understand Twitch culture. Re-entrant monitor lock auto enter lock monitor. Proof of lock. See, that's what I want. A proof of lock. Yeah. Okay, so here's what we're going to do. We are going to make it so that instead of taking a lock each time, we're going to make the caller pass in a proof of a lock for each of these, so that the caller must take a lock first. Is that right? Begin list. So it's almost pass through, but not quite. I like that. A proof of lock. And what? Proof of lock. We don't do anything with it. We just want it. And then we can just, can we do that for each of these? See, what I like about this, again, is that we don't have to hold on or do any locking ourselves. We're just asking whoever uses us, hey, do the right thing. Take a lock. Make sure that you've taken a lock. Guarded by. What is Moz guarded by? Mozguard var only indicates a shared variable should be guarded by any lock. Mozguard var is primarily used when the client can express the name of the lock. That is our situation. Mozguarded var. And then we don't hold a reference to that. Okay. Now will you build? I guess we don't have to say build with anymore. Kappa is used to convey sarcasm or irony. Kappa. Kappa. All right. Okay, now what are you complaining about? Now I think it's more worried about semicolons. All right, stop your moving. Hides overloaded virtual function. Oh, come on. All right, so I have to update the interface, the Abstract interface. And then I did see also that there was expected semicolon on line 127, which is down here. Yeah. Okay. How about now? Kappa. Okay, still upset. Still upset. It doesn't like... Oh, it's warning. Requires holding any mutex. Right, we've got a... we've got a lock, a proof of lock. Can I do anything with it? Proof of lock. I guess what we'll do is we'll just remove that guard. Moz guarded by. And then what else is it worried about? These are all just warnings. So I think it's actually going to build. That's nice. But we can get rid of this. So that builds. And now what I want to do is to be able to construct one of these things. Jump list builder. When we created jump list builder, how does this work? We'll create a jump list builder. We'll create an instance of it. I think we'd written this down, like that we wanted to like have a way of doing it natively. Native. Let's update WinTasker to have a new method that can be accessed from native code called like do create jump list builder. Have it take an argument that is a reference to something that implements jump list manager interface. Have jump list builder move that thing to the background thread. The background thread owns it. Then in our case, have our gtest call do create jump list builder, passing it something that mocks out jump list manager. And then call its populate jump list method for testing. Mocks out jump list manager. Okay, so we'll update this function. See, it's called using do create instance. Do create instance. You almost want this thing to be able to take a class as an argument. I think that's what I think you can do that. Looking for some Mozilla code though. Testing the no, not third party. This is not quite. These are macros. Copy from. C++ class as argument. To introduce class to declare any. So yeah. Oh, so what I'm looking for is if you want to pass the class itself. Oof. Templates. That's not right. That's an instance. So something like template class. So that's a string type. Address type. Crash reporter. Type def int address type. Yeah, I worry that I am getting too clever, and C++ is not. That's not a good idea as being clever in C++. what I wanted to do was pass in just something like the class and then have this wrap jump list manager. So, I mean, I could. What do I want to do here? I want to make it so that I can sub in our fake one. So I can use our fake jump list implementation. So we have a couple of options. We could add a method onto jump list builder. That lets us, after already getting access to the native one, the real one, we replace that with our fake one. I think there's a pattern that. Hang on. For testing. Yeah, build time. The problem is that that's a build time flag. So Akris just suggested something like this, but I think he might be being sarcastic. The problem is that this is a build time flag, if def, and we want this to be runtime. What happens if I say NSI jump list builder script state pointer native. Okay, I could do something like this. Native jump list. What did I call it? Jump list manager pointer. Jump list manager pointer. And then we can add script. Void override jump list backend for testing, taking in our jump list manager pointer, and then we can implement this. Here. Jump void ns result. As hang on, load URI for the no stripped. Load URI. What is the it's ns result, I think. Or does it use NSI method imp? Okay, NSI method imp. Jump list builder, and then it takes in a jump list manager, We're gonna just return ns okay here. Let's see if that builds. In how many places is jump list builder constructed? I think it's just the one place. All right, what are you complaining about? Jump list builder is constructed in Windows jump list. We create one for private windows and one for normal windows. If it's just for the test, maybe you could set an OS environment variable like test, and depending on set, do different things. Yeah, maybe. Use an environment variable. Valid syntax. What's wrong with that syntax? Do you want the name? You want the name of the variable? Okay, fine. In jump list manager pointer, testing jump list manager. So you could make a common interface jump list builder with two concrete implementations. Yeah, that is the plan. That is what jump list manager is. Just so we're clear, I feel like maybe I haven't been communicating properly. That is the plan. Jump list manager is implementing jump list manager base. Oh, that is what we want the pointer to be. Jump list manager base, not jump list. But yeah, we're gonna have two concrete implementations. This is the real one. This is the one that's just passing through and writing to the native jump list manager, and then jump list manager base is gonna be. We're gonna implement another one for testing. That's the idea. Manager base pointer. Manager base. I still didn't like it though, by the way. Why didn't it like it? No. It doesn't like it because unknown type name jump list manager. The compile jump list managers. Never heard of jump list manager. Okay, how does this work? Includes. Oh, I see. I have to do this. Class. So I'm gonna say dump in some native C++ here. And say class jump list manager base forward declare. see if... Oh, no. Wrong operating system. Let's see if it likes that. Seems good, says Ocris. All good. Good. Nope. Doesn't know what Jumpless Manager base pointer is. Type Jumpless Manager base pointer not found. Jumpless Manager... Oh, base pointer. Okay. Out of line definition. Oh, right. We need to update this manager backend for testing. Jumpless Manager base. And then what else was it complaining about? Unused variable on line 389 of jump list item. Oh, so you're right. Okay. All right. Now, if we can get the actual implementation, like if we can get Jump List Builder to use our Jump List Manager base and call into it, I'll be pretty happy for today's work. It does not match any declaration in Jump List Builder because type of first parameter of member declaration does not match definition. Jump List Manager base versus Mozilla widget jump. Oh, of course. So this needs to be in the right namespace. What was it? Mozilla widget. Namespace Mozilla. Namespace widget. Widget. And then this needs to be native Mozilla widget base. Try that on for size. Linking. It linked. Okay, so that's a good sign. I mean, it doesn't mean it's going to do anything now. All we've done is we've exposed a function that allows us to do nothing. But I think the next step is going to be the crucial one. What we're going to do is we're going to make it so that whenever the jump list manager, or the jump list builder, rather, is constructed, we're gonna start by changing the type of jump list jump list manager here. And we're just gonna call this thing Yeah, I like that. So it's like, what What do we want here? We want atomic. Or want like a unique pointer, I think. Unique pointer. Of a jump list manager base. Jump list manager. Yeah. And I'm going to put this, it's probably going to want this up here actually. Actually, let's see what happens if I try and build this. I mean, it's definitely not going to work. It's going to be pretty upset, I think, by a bunch of things. But namely, we need to construct unique pointer. Oh, I want this thing to be ref counted. How do I do that? How do I make it so this thing is ref counted? I don't have to manage memory errors. This is like a... this is what happens whenever I'm used to Mozilla classes and XPCOM stuff where we get a lot of like ref counting for free. This is a bare thing, a bare class. And I need ref count. I want ref counting. Declare ref counting. Not DOM. I don't want it in DOM. I want an example of us doing it somewhere else. Inline declare ref counting. Yeah, what is this? Inline declare ref counting. Use macro to declare and implement the add ref and release methods for a given non-XPCOM class. Yes. Yes, that's what I want. Inline declare ref counting. But jump list manager base. Then this needs to inherit from it. Inline declare ref counting inherited. Yes, we need to inherit it from this here. This is public. And then declare it being inherited from jump list manager, inherits it from jump list manager base. No semicolon. And then I actually think instead of a, do we want unique pointer? I need to remember what unique pointer is. Unique pointer. Smart pointer wholly owns a resource. Ownership may be transferred out of unique pointer without explicit action. Similar to auto pointer. Yeah, that's good. Being movable rather than copyable. So this is just a way of being safe and not making it so that people can easily get a copy of our pointer. It has to move. So unique pointer should still work. All right. Now that we've got our ref counting. Interesting, but the functions use ref pointer jump list manager. Yeah, but unique pointer is, I think it's okay to use ref counting, I think. Let's ref smart ref pointer. Maybe it shouldn't be. Add ref release. Make unique eliminates use of new. If objects are only created through unique pointer, then assuming all explicit release calls are safe, no leaks are possible. Make unique. Okay, maybe I do want ref pointer. Maybe I was wrong. Now it's really upset. Yeah, I think this is what's going on here, is it needs to be a ref pointer. Thanks, Ocris. Thanks, compiler. I'm still not convinced that this is going to be happy. Yeah. So what are you upset about now? So many errors. Okay. Reference counted class jump list manager base should not have a public destructor. Make this class's destructor non-public. Okay. Can do. Private. Ref marked override does not override any member function. And that's because jump list manager base wasn't declared properly. Okay, let's try it now. What other errors do we get? Man, this reminds me of my days working on Thunderbird. I was doing a lot of like native code stuff and having to grapple with XBCOM and all these macros. Back in the day. Okay, now you're upset because addref marked override does not override any member functions. So I think that's because it shouldn't be inline declare ref counting. I think it should be inline impl ref counting. No? Inline declare ref counting. Oh, to declare and implement. Param optional override market methods as overrides. Declare inline declare ref counting inherited error. Add ref marked override does not override any member functions. Ref counting inherited. Note expanded from. So jump list manager base doesn't have. Use a method to declare and implement add for a given non-expandable class. Ref counting with destroy. What's with destroy? Declared virtual. What is with destroy? Statement that is executed when the object's ref count drops to 0. I don't need that. Declare virtual. As I method. Pure interface class. I want to be able to reference user info. I don't want to provide a ref counting notation. Virtual, pure virtual ref counting. Maybe that's what I want. I want pure virtual ref counting. Yeah, that's what I want. Hello. Oh man, haven't worked with C++ in years. How's it going? Asks our Cousineau. It's going. C++, not my lingua franca. I mean, I can understand, I can read it and make some sense of it, but especially, I mean, there's so many layers here. There's C++, which is already not something I'm super comfortable with. Then there's Mozilla's flavor of C++ and all the macros and utilities, and that's another ball of wax. So it's going okay. It's going about typical. Really just trying to figure out how we can implement ref counting here. Although, now that I think about it, no, okay, unique pointer. Yeah, we're ref counting. That's right. It has a private destructor. Temples Builder H. E725. Virtual. Maybe I don't need that. Conversion. Right, and then we start getting into the reasons why I expected it to be broken, which is that over here, M jump list manager. Here, we need to say new jump list manager, jump list manager. Okay. Now it's still upset about some things. It's a lot of repetition. No viable conversion here from here. Note, 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 note. And then and here's the next error. No viable conversion. Okay, so we got rid of our candidate no known conversion from ref pointer. I think we got our ref counting, like our ref counting stuff done. It's now, it looks like it's complaining about ref counting, but I think what it's actually complaining about is that the interface that we're talking to is changed, which is expected. Make a lazy thread for any IO. Let's just do that for now. Not my best work. And then let's not do this. Already I see that we need to implement something else. We need to implement set app ID. Okay. Virtual. I presume that Microsoft. H result, yeah. So we're gonna take in, what is the LPC wstir app ID, and we're gonna implement that down here. And return one. I have to look into what that means later. We're gonna call set app ID, which I'll do. Yeah, that works. But we also want proof of lock. Same thing as before, proof of lock. Proof of lock. And then we'll say set app ID. Okay. So that should work. SAP user model ID. So ancient lock. We're gonna not do this anymore. I'm gonna just disable that. And then we're gonna say proof of lock. We're gonna pass in our lock here. Whoop. And then here. If not available. Destination. This is not gonna work. We're gonna succeeded. We're gonna pass in lock. Does it have a board list on it as well? I have to have a board list implemented. Result abort list. Abort list, proof of lock. Comment that out. Begin list. Okay. Where's our lock? It's right there. Jump list manager, you do that. That, I think, works. And then what else? We're not going to do this. We're not going to do this. Nope. Jump list manager. Commit list. Proof of lock. Delete list. Oh, there's so much more we have to implement. Okay. Delete list. EW stir. Okay. And delete list. Lock. Manager, delete list. PS said. Pass that along. Hang on. Let's start from the top again. Here. Yes, that's okay. We construct it, we assign it, we wrap it. Here, we have to do this. Here, we'll go. Yes, and then add jump list manager. Here. And then add user tasks. We have that one, right? Yes. Append known category. Oof. man. All right. Jump list manager. Append known category. What's that one? We were gonna want this. Known desk category. Is that something that's like? Are we gonna know what this is? I'm gonna presume that that is an enum that we know about. That's in scope here. Okay. Here, let's copy this. It's 2:28. I'm gonna wrap up in a few minutes, but I'd like to get something compiling. That'd be nice. Append known category. Proof of lock, and then what was it? Known desk category. Category. Append known category. Okay. Same thing with this one. Oh, we need to pass in the lock. Pass in the lock. Oops. And then jump list manager, append category, pass in the lock. Oh, hang on. Find previous. We weren't passing in the lock here. And that is almost it. Find previous. Jump list manager. Begin list. Lock. Jump list manager. Add user tasks. Append category. Oh, jump list manager. Jump list manager. Commit list. And that, my friends, might be all of it. Let's just see what happens. I will be very surprised if this builds right out the gate. But let's see what happens. Missing line. Oh, hang on. Boop, 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 boop. We got late breaking. Because you're not inheriting from FCAM at line 280. I don't think he'll see you, says Smurf D. I'm seeing people, but I don't know if I can see what you're seeing. 280. Begin list. Okay, I switched it. The formatting's garbage, but I switched it. Let's see what happens. I'm hoping I can just run like Prettify or whatever it is, some kind of like restyling on this file. This file is such garbage formatting anyways. Okay. It doesn't like it. It's very upset. And the reason for this is warning. It hides an overloaded virtual function. Jumpless Builder H97. Oh, yeah. I forgot to put that in here. Okay. Too many arguments. Yeah, okay. And then a lot of notes. Let's try that again. The comma is missing. Come on. I mean, you're all so good. You're all so good at, like, catching my mistakes. Is the comma missing? Where's the comma missing? Line 280. Line 280, the comma. Oh, of course. Thank you. Thank you. That's what they were saying, lol. Okay. My bad. My bad. I I should have done a better job of reading the chat. Thank you so much for finding my missing comma. Good eyes. Good eyes, gang. Woo! So it's linking. Holy smokes, it linked. Okay, not quite. Not quite. We're almost there. We're almost there. Undefined symbol referenced by Jumpless Builder H91. Okay, our ad reffing is upsetting it. Or like we need to actually implement the ref counting is what it's complaining about. We declare it. So instead of declare ref counting inherited, who extends resolver? Who uses this? Class resolver. Inline declare ref counting. Override. Yeah, okay, that's what we want to do. Declare ref counting. Jump list manager. Override. Those are only visible to the pair passenger. Not sure what you mean there. Are Cousineau? If this links and we get I'm not even going to look. I think we're going to end the stream right there. If this finishes linking and it links successfully, I'm just going to end the stream and say, call it a day. Nope. Undefined symbol. Now it's worried about the destructor. So it's not. Oh, undefined. So we need private, virtual. Oh, I think we just need like a default destructor on the Jumpless Builder here. Or maybe just like equals default. Isn't that fine? Yeah, virtual. Don't you need to also inherit from some ref counted class? No. The good news is, I think, if I understand this correctly, we've declared the virtual ref counting functions with this macro, and then we actually implement them here saying that we're overriding. So I think we're okay. Warning, warning, warning. Delete colon virtual function, non-virtual destructor. Okay, still upset. Abort list. VF table. Undefined symbol. Undefined symbol. Undefined symbol. What does that mean? Like, undefined symbol. Do I need to say that each of these are overrides? Smurfy asks, have you included the reentrant monitor.h? Maybe you need virtual destructor in both classes? Maybe I do need the virtual destructor in both classes. And maybe... maybe do I need to say override? Let's see what happens if I say override. Well, the thing is, these are inline declarations too. I'm not. Well, here's an inline declaration. Override. What happens if I put that in there? Let's see. Override. I haven't done a lot of this style of C++ in so long, and I'm doing some guessing here. Unfortunately, the compiler messages, the compiler errors are pretty cryptic. Maybe I have to put virtual in front of them too. That could be. Virtual override. Let's see what happens. Let's just try. And if this fails, no matter what... static assertion. It does not like something. Stack assertion failed due to requirement that a reference counted class should not have a public destructor. Make this class's destructor non-public. Whoopsie daisy. They both have to be non-public. When did I last I'm just trying to think, like, when is the last time I like did a bunch of C++ overriding like this, like, and like learned deeply what it meant? School. Warning: explicitly default. The destructor is implicitly deleted. That's a warning. Warning: deleted function cannot override a non-deleted function. I wonder if I don't even need this destructor anymore, actually, because we'll just inherit. Still mad. Deleted function, jump list manager overrides a non-deleted function. The override function is, yeah, here. So not quite. Maybe it's jump list manager. That slightly different. It should be at least protected if you inherit from it. Yeah. Okay, fair. I need to look at some examples. Protected destructor. Maybe that's what it is. Yeah, protected. Let's try it. Compiler linking got a bad day. Compiler linker is just doing its best. It's just having a really hard time explaining to me clearly what the problem is. Say what you will about the Rust compiler. I know people really struggle with Rust, but I think it does a way better job of explaining whenever things have gone wrong. Linking. Hates it. All right, we're going to call it there. It still doesn't know what I'm talking about. So we've got undefined symbols for some reason. And we got to figure out why that is. All right, well, we're going to call it there. Thank you so much for watching episode, whatever this was, 318 of The Joy of Coding. We got closer today. And I think we're almost there to the point where, like, we've got our shim. This is basically a shim is what we're putting in, which will allow us to, like, swap in our testing class. our testing implementation, and then we'll be off to the races. I hope. So we're getting there. So let me amend and call it there. Thanks again for watching episode 318 of The Joy of Coding. Let me know what you thought. There's a link at the bottom of the agenda to this rate this episode form. You can let me know what you think. You can ask me questions. I'll do my best to answer them during the next episode. So go ahead and fill that out, and I will hopefully see you next week. Have yourselves a great week, everyone. Take care. Bye-bye. Hold on a second.
The joy of coding.
See ya.